Last two classes we were discussing about user defined functions. Now we know how we can define and use user defined functions including recursive functions. And the topic that we are going to see today is how arrays can be passed as arguments to user defined functions. So, the topic for today is passing arrays as arguments, and before we see how we can pass arrays to functions, let us look at what are actual and formal arguments. Arguments are also called parameters. We can try to understand this using an example. Here we have a function named area which is returning a real value using the type float, and it is also receiving an argument which is fr, which is a floating point variable r, and in fact this is a function to find the area of a circle. The radius is obtained as argument, and a local variable for area is created and the value is found and returned. So that is the function. And here the main function of this program is making use of the function to find the area. It just asks the user to enter the radius, and then it makes a calls within the printf statement to the area function and just prints it, and that's it. And here this argument which is used in the definition of the function is called formal argument, which is a local variable in the called function. Here the called function is area and the calling function is main. So the argument which is declared in the called function, now this is declared as a floating point argument. That means it can receive a value of the type float or type compatible with float, meaning it could be double or it could be int. If you pass an int, that can also be received. So that is a formal argument. So the arguments which are declared within parentheses of the definition of the called function are called formal arguments or formal parameters. Now, if you look at this is the function call, this is the function definition to which there is a call. There could be any number of calls, and each call you have to pass actual values of arguments which can be received in the function definition or in the function instance created on the stack. And here this is what is called actual argument, and that could be a local variable in the calling function, in this case main, whose value is passed to the calling function. So whatever be the value of this is passed. Or here you can use directly a value compatible to float, or you can say here I can pass 1.5 if you want, if I want, and or you can pass 10, a decimal value you can pass, or a double precision value you can pass. That is what I mean by compatible. Or it could be an expression whose value results in a data type compatible with float. For example, I can say 10 into 2.5 I can say, or an expression involving variable, so that the result is a floating point value. That's it. I hope this is clear. So these are actual and formal arguments. So the take home is the arguments or parameters which are declared in the function definition within this parenthesis are called formal arguments. And see that here the variable names are different. And you can use any variable names. From the last day's discussion, you know that whenever the function is called, a new instance of that function is created on the stack. So every instance will be having a separate variable created for that instance. So it doesn't matter what variable name you are using here. So what matters is the data type. If you declare that formal argument as of type float, then when you call that function, you can pass a value which is compatible with this data type. So the value can be represented either by a constant, a variable, or in general an expression. So these are formal arguments, and whatever you pass during the function call are called actual arguments, because those are the actual values passed on to the function instance to be created. Now we are coming to our topic. First we will see how we can pass a one-dimensional array as an actual argument to a function, and we will also see how we can declare a formal argument to receive a single dimensional array. First we will see an example, and later we can formalize the syntax. So here is an example. There are two functions foo and bar, and in the function foo, if you look at, you can see that the only data object is an integer array of size 5. That's the only data object. And now suppose the function foo is invoked or called during execution. So this is the function which declares only one data object, which is this array, and what is it doing is it just declares the array. So nothing is stored, undefined values at every position. Then it makes a call to the function bar by passing the array as argument, and after that it just prints the array. That's what it's doing. Now suppose, and what is this bar doing? If you look at what bar is doing is, at every position it assigns a value. What is the value assigned? 10 plus the index. So at index 0 it will get 10, at index 1 it will get 11. Likewise at index I it is getting 10 plus I. That's it. Now suppose this function is invoked during the execution of the program containing these functions. Maybe the main function is calling this. You know from the previous class that the moment this function is called, an instance of foo is created on the stack. So memory is allocated for the single data object of foo, which is this array with 5 locations in it. And assume that the memory is allocated like this. This is the first index, 2 bytes, second index, likewise it goes. Now if you simulate the execution of this function, it comes to the first executable statement, which is a function call. Now you know from the previous discussion that the program control should go to this function which is called, and the moment that function is called, an instance of this function needs to be created. And that's very interesting in this case. Now the function call happened, an instance of bar which is being called is created, and the data object I gets memory allocated. So then why memory is not allocated for the formal argument? This is an interesting question. Then how the array is passed? So here I am claiming that when the instance of bar is created, only I is getting memory allocated. That means the formal argument to receive an array is not getting any memory allocated. You can see that previously this was what this particular program got allocated in memory. Now when that instance is created, only the variable I is created. Now this question, and to answer, when an array, here a array, is passed its memory address, which is this 500, is passed to the called function. Okay, from the lecture we defined single dimensional array. We know that the address of the single dimensional array is nothing but the starting address of the sequence of locations allocated to the array. So it's 500. So in the C programming language, when you pass an array like this, what is passed is actually the address of the array, and that's very clear because we know that the name of the array is nothing but the address of the array. So that is what is passed, and thus the called function, that is bar, gets access to the array instance created for the calling function. That means the address 500 is passed on to the called function. So when you are accessing the array, in fact you are accessing the exactly the same memory object created on the memory for the calling function. So when you are passing array, the array is not copied, but the same array instance is shared between the calling function and the called function. It's very important. Okay, this is what is called pass by reference, because a copy is not created, but rather the address of that data object in the memory is shared to the called function, so that the called function can access that data object. And hence both A array, that is the actual argument, and B array, that is a formal argument in this particular call, represents the same data object in memory. Okay, so this is what is happening, and now see that whatever change that this function is making on the array will be reflected in the calling function as well, because actually this function is modifying the array created for foo. Okay, now if you proceed simulating this function, what is it doing is it just assigns 10 plus I to every index. So if you finish this function, this is what is happening. Okay, that's very clear. It's getting values like this, and the value of I becomes 5, and now this is a return statement. You know what is going to happen. The control will be returned out to this point, and now see that the instance for this particular function which is created, which is only variable I, is deleted, and you are coming over here and see that whatever change that you made within bar in the array is accessible to foo. Okay, in some languages it is called side effect, because the calling function's data object is getting modified in the called function. Now it progresses to this statement, and if you print the array, you will get this array values printed. So with this example, I think you got how function calls executes and arrays are passed. This is called pass by reference. The address of the data object is passed on to the call function. Now the function returns to the point where foo was called. Now we can formalize the syntax of this function call first. So see, this is the syntax. What is it? The function name, in the previous case it was bar followed by the array name. So this is the actual argument, that is the array to be passed. Just use the name of the array. The square brackets are not required, and you know that this is nothing but the address of that particular array. Okay, and same array instance is shared between the calling function and the called function. That is what we saw. So whatever change that the called function is going to make will be reflected in the calling function. So this is a way of returning multiple values from the call function, because all the array elements are like returned. Now the other part, how will you receive an array, that is formal argument. So this is the syntax. What's that? First is the data type of the function, that is in the previous case it was bar and I think that was void, whatever value is to be returned by this particular function. Now the function name, and then the formal argument specification. As usual, it is the data type of the formal argument followed by the array name, and not that here when you declare a formal argument as an array to receive the address of an array, you don't have to specify the size of the single dimensional array. So that is an important thing. So this is the syntax for receiving an array, which is how you declare a formal argument for receiving an array, and not that the address is passed and the address can be received like this. Now with this I am giving you an exercise problem. So you write a menu driven program with one function, user defined function for each of these functionalities, and you also add an option to exit also. Then you can allow the user to repeatedly go for any of the options. Okay, and this is just for you to practice how arrays can be passed, and you can access the modifications from the call function. Now we are going to see how you can pass a two-dimensional array to a function, and here we are directly going to see the syntax of function calling. So this is the function name followed by the array name. It's exactly the same, no difference regardless of what is that array. Maybe it's one dimensional, two dimensional, or three dimensional, the syntax is same. Okay, this is what we know. The array name represents the starting address of the array, and the same array instance is shared between the called and calling functions. Now receiving, how will you receive, right? That is important, and this is the syntax. Let us see which are the components in it. First is the data type, that is the type of the value to be returned by this function, followed by the function name, then the data type of the array to be received, and then the formal argument specification, that is the array name. Here you can use any array name, need not be same as the array that you are going to pass, any name, and here you note that you have to use square bracket one for each dimension. It's a two-dimensional array, so two dimensions are there, and if you recall, in the case of a single dimensional array, we don't have to specify the size, and for a two-dimensional array there is the row size and column size, but you have to specify the number of columns. You don't have to specify the row size, but you have to specify the column size. So that is the syntax, and I am leaving the following as a search exercise for you. You find why the column size is not required, and then how it knows that how many rows are there. Okay, if you are interested, search in the internet and try to find why is it so. And with this, I am coming to the last slide where I am showing you an example. So this is an example where foo is foo is calling bar with a two-dimensional array. Okay, so this is how you declare the formal argument. Only size 2 is required over here, and when you pass, you just pass the array name. So with this, we are finishing this lecture, and I am giving you, for you to practice and understand how you work with two-dimensional arrays and functions, I am giving you a homework exercise. Actually, all these problems are already solved. You just now write it using functions, and that's it. So today we have seen how arrays can be passed to user defined functions or even a library function. This is how you pass. We saw how the actual argument can be written. It's just the array name representing the address of the array, and formal argument when it is a single dimensional array, the size specification is not required, but the square brackets are required. For a two dimensional array, for the formal argument, two square brackets are required, a pair of square brackets are required, but you have to specify only the column size. And we also have seen what are actual arguments and what are formal arguments. Thank you.